This is a quick video on differentiating trig functions. Before we begin our first example, let's just first of all discuss an acronym that will help us with differentiation. PRAT. So the P stands for power, the R stands for ratio, and the A stands for angle. The T is just because it's trig. And these are the steps that we need to consider in a differentiation of a trig function, and it's the order in which we'll do them. The power part of this rule is not always a feature, so I'll first of all do an example that doesn't involve a power, and then I'll show you what to do when we do have powers involved. So our question is y equals sine 3x plus 5. We want to find dy dx, and the first thing that I would do in a question like this is have my log tables to hand open on page 25, and on page 25 they give you a list of some common derivatives, and they tell us that when the function is sine x, the derivative is cos x. Okay, so that's just an important feature to remember when we begin to differentiate. So looking through our steps, power, P for power, there isn't a power on my ratio here. I don't have a sine squared or sine cubed, so I don't need to worry about that step. So I'll just skip it and I'll go straight onto ratio. So ratio just means sine, cos or tan. And so here it's sine, and as I've just discussed, sine x differentiates to give you cos x. Now just watch out, because I don't just have straight up sine x here, I've got sine 3x plus 5. So I'm going to differentiate that, and I'm going to write down that dy dx equals to sine differentiates to give cos 3x plus 5. So that's the first part of my differentiation done. But I'm not finished yet, because I still have to differentiate the angle. Now in this case, the angle is 3x plus 5. So I want to differentiate that, and I'm going to get 3. It's important to bear in mind that this 3 is multiplying by the whole expression, not just by the angle 3x plus 5. And I'm going to finish off by tidying up, and that just involves me putting the 3 out in front. So my derivative is 3 cos 3x plus 5. Okay, let's look at a second example. So same type of thing again. So in this case, I've got y equals tan x squared plus 2x, and I want to find dy dx. So I've got my acronym there again. PRAT, power, ratio, angle for trig. Now, power, what do I mean when I say power? Well, it looks like there's a power in this one because I've got an x squared, but when I'm talking about power in trig functions, I'm really talking about a power on the sine, cos or tan, so a power on the ratio, and I don't have a power on tan, so I don't need to worry about that step, and I'll go straight into ratio. Remember to have page 25 open in your log tables to look this up. So when you differentiate tan, you're going to get sec squared. The angle will just stay as is for the moment. So this is the ratio part of my differentiation complete. And now I want to multiply by what I get when I differentiate the angle. So this time, the angle is x squared plus 2x. So I'll differentiate that, and I'll get 2x plus 2. Now you'll note here that I've put a bracket around this 2x plus 2, and that's just again to indicate that this 2x plus 2 is multiplying in its entirety by everything that came before. And so really to finish off then and tidy up, I should write whatever I have at the end here it's multiplying on, just write it in at the start in a bracket to make it clear that it's multiplying by the rest of the derivative. And there's my final derivative then done. 2x plus 2 times sec squared x squared plus 2x. You might be wondering what sec is at this point. You can find out quite easily by looking on page 13 of your log tables, where they remind us that sec theta is just 1 over cos theta. So it's a familiar ratio, just written in a different way. Okay, so this time let's look at an example that incorporates a power. So here we have y equals sine cubed 4x. So again, I'm looking back there to my acronym, PRA for trig. Power first of all. Now this time I do have a power on my ratio. It's that 3. And I'll deal with it just like I've done with every other power that I've differentiated previously in algebra. I'll bring it in front, and I'll multiply by it. And I'll also reduce the power then by 1. And that will give me 3 sine squared 4x. Next, I'm going to differentiate the ratio. And when I'm differentiating ratio at this point, I ignore the power completely. I just look at the ratio part. So I'm differentiating sine, and I know that sine differentiates to give me cos. So I'll write down cos 4x. Notice I don't have a power with it. It's just the ratio that I've differentiated, and I've kept the angle the same. And now my last step is going to be to differentiate the angle. When I differentiate the angle here, I'm just going to get 4. And at this stage, my differentiation is done. All that remains is for me to just tidy it up a little bit. And really all I have to do is take whatever coefficient I might have out in front, whatever the result is of the derivative of the angle, and multiply them together. Just keep your eyes peeled in case there's any minuses along the way. There's not in this case. So my result is 12 sine squared 4x cos 4x.